Hey there, this is Richard from animate.com. Welcome to another tutorial on UV spectrum. Today we're going to have a look on organic models and how to shade them using the UV spectrum add-on. Before we start, I want to check the model itself. It's a dinosaur model and we need to go into edit mode, because if this model was made in another program, in another software like Maya or Cinema 4D, it might be that the local coordinate axes are rotated 90 degrees so that the y-axis is looking up. So if you switch to local coordinates, you might see in what direction the x, y, z axes are facing. In order for UV spectrum to calculate the maps right, you need local coordinates that align to the space coordinates. So the local x-axis should look to the global x-axis, and the same for y and z. Furthermore, if we're using x equals minus x, because we want to have a symmetric pattern of gradients and color ramps, then we should assure that the symmetry axis really is the x-axis, so that the plus x side of our model looks the same as the minus x side. In order to achieve that, we might want to rotate the whole mesh for 90 degrees. For example, if I want to rotate it, for example, if the y-axis is looking upwards, like in that case, you see the green arrow is now facing upward, then I simply have to enter edit mode, select all by hitting A on the keyboard, and rotate everything 90 degrees around the x-axis, meaning I hit Rx minus 90 on the keyboard and hit enter. So now the z-axis, well, it's not looking upwards, it's looking downwards. So that was a bad choice. I have to rotate it for 180 degrees around the x-axis. So I hit Rx 180 on the keyboard and hit enter. Now the blue z-axis looks upwards on the model. All I have to do is to rotate the whole model in object mode again against the x-axis. So this is the axis alignment which we need in local coordinates of our object. So once we're done, we can choose the parameters for UV spectrum. For organic models, we want a low segment bias, 1% would be good for a start, and no smooth steps are needed. But let's make some 5. Organic is chosen because it's an organic model. We don't need adjacent segments. We need symmetry. Again, this will lead to a symmetric look of our color ramps, which we're using in combination with the maps. And we don't need the mark seams options. Right away I hit map selected and the UV maps are calculated. This will take a few seconds because it's a very low poly mesh. This is done quite quickly. And he's done already. So the maps are calculated, and in order to see them, we need a material that uses them. For this, I'm going to add a color ramp to our diffuse shader and an UV map node, which I will separate into the different channels, the components of the node. everything is connected, and I choose the first map, which is the dirt map. In order to see it, I will choose the rendered viewport mode, and here I see some convexity gradients along the mesh, which is nothing else than the dirt map which we calculated, in this case just the X component. So this would be suitable to color the muscles. Again, we see the Y component here even better, so if we make some flashy color, you can imagine that this soon will look very organic. Yes, just like the other way around. So there is some fat between the muscles, and the more bulgy and convex the surface gets, the more reddish it will become. So this would be suitable for anatomic coloring. I will switch that back to black and white. The dirt diverge map is a good gradient along the z-axis. So we see that the local z-axis alignment really matters here, because this is exactly the direction in which the diverge will be calculated. That's the same case for the divergence Z map. Here, the X component of the dirt diverge map and divergence Z, like said before, will also have some gradient along the Z-axis. It's not that obvious in that case as it was for the dirt diverge map, but still the Z-axis plays a role in this map. And the flow gather map is a very smooth solution, so if you want a smooth gradient covering the whole mesh, then flow gather will be a good choice. The flow is based on the intrinsic convexity, on the local convexity of the mesh, and it is recalculated and summed up point by point, running down, resulting in the Y component, which is the gather component. So the Y component represents how much dirt is gathering if dirt would be running down at special points of the surface. So that's mainly it. The other, like seams, we haven't calculated seams, so this is not useful now. Segments won't be that useful because it's better for mechanic and engineered models, which actually really have 90 degrees angles and would be segmented. The same for texture, because texture is based on the segmentation. It won't be very useful here because you see 90-degree angles here. So I'd say we color our model by using the first 4 UV maps here. Let's make a quick setup for our color. For the flow gather, we said we are making a smooth gradient. I'd say something greenish brownish, as it's a typical color for dinosaurs, at least in movies. And here I'd like some orange reddish color. That's that. To get more complexity, of course, we will mix colors and mix them by using different maps. So let's take here the diverge, just in order to see the map. Let's have a look how this looks. It's not really useful. that's very low. Okay, that might be good for spots. Yes, they are even symmetric. Okay. Well then, let's use them. I assume that the values of this map are even in a negative area, so I will add a little. Yes, there's really something going on here, although I already added 0.3 to the value. So this helped to get a smoother result. Okay, so yes, let's make this with some extreme coloring, because later on we will combine the colors and it won't hurt if we use intense colors here, because by mixing they will become grayish again. What else? I'm sure we can use the dirt map, because it has a lot of detail on the convexity of our model. This one here. Here I'd like to make a gradient between a dark gray and let's make some sandy bright color. So that's mainly it. I'm now choosing Mix RGB node. I want to mix the first two gradients, and either I simply mix them, which means they are all mixed alike on the whole mesh with let's say 50-50, or I choose another input for the factor so that along the mesh I have some variation of how much one gradient is mixed into the other gradient. For example, I could use the X component of the flow gather to do so. It's not very contrasty, so I don't see that much effect. Let's choose another one. Yeah, for dirt, I see some variation here. Well, that's nice. What else? We could use the third gradient, and this time I wouldn't just mix it. Let's have a look what happens if we multiply it or if we overlay it. We get a slightly better result if we don't simply mix it one on top of each other. And again, I'm using one of the components to control the factor of the color mix. So you see that you get a quite complex scattering of colors by using different color ramps in combination, and choose different UV maps as input of the color ramps. Last thing, like for the barrel in the game asset tutorial, I want to add a noise texture to get a little more detail, especially for close-ups. And then we're going to have a look on appending the monster skin material on that. So if I want to combine this with a fractal noise pattern, it's good to add the noise factor before we input to the color ramp. So this is what I'm talking about. Add a noise factor with a math node add. This might be too much because we now offset out of our color ramp onto the onto the values higher than 1, and to change that we are simply changing the amplitude of our factor here, of our noise factor. So I multiply the output with a low value like 0.2 in order to see the spots. Simply scale them up, so you see some variation here. They are even smaller now. And this is just for the first color ramp. Of course, we will do this with all the others as well. Okay, same here. I have a math node already, and I will duplicate that for the last color ramp and input the amplified noise in the last one as well. And we are achieving a spotty skin with this technique. If we want to have more contrast, we can add more marks in the color ramp and simply move them together. Something like this, so that some borders appear. If we look closely here, we have a line now, and here as well. Fortunately, the noise is distorting these lines, so they are not that straight. Alright. Let's make this gray. So the gray becomes brown smoothly. Right. That looks nice. I want more of that. It should be more obvious, so I will slide this little border to somewhere where it's really filling the whole mesh. So you see, combining the UV spectrum maps with noise texture, make more detail, will add even more complexity, and of course the noise texture will have a very good way to add detail. Okay, so next is how to append the monster skin material and how to deal with that. What we've done now is a nice color scheme which we can group and save for later use. So I will simply select all nodes which make the color, and let's join them in a frame. I already appended the monster skin material. So now I'm going to append the monster skin material from the material library. For this I'm going to File, Append. We are already inside, no, that's another file. Here in the pack, from UV Spectrum, I select the material library, go to material, and there the monster skin is. I will choose it from my material list, and right away I get a very reptile-like cell skin. Let's have a look at the different nodes here. We might want to adjust the bump because I see some black spots here. This is due to the very heavy bump value. Let's check these. There's one bump on 1.5 and another one on 2. So if I lower them to a value of 1, the black spots will disappear. And of course I have several color inputs as well as a very important scale factor. This we want to adjust to our mesh. Let's just choose some different value and you will see how the small spots and cells of our skin are bigger and smoother now. Same holds for the noise. This is a small distortion in the cells. And even low values like 1% of noise already makes a very irregular stretching and distortion in the cells itself. So let's say I'm happy with that. I would choose a smaller cell scale, but for this tutorial it's good to see them clearly, so I leave them at that scale. You can choose a special vector input in which they should be mapped onto the mesh, but in most cases generated vector input should be fine. And we made a color scheme before. I want to use that in this shader now. So I switch to the other material which we made. And now I'm going to copy the whole frame. So I select all nodes and hit Ctrl C to copy them. And I go back to the monster skin, I guess it was this one, and hit Ctrl V to insert the nodes I just copied. So here we have the color output, and I will plug it into the green orange and this dark green area here, and more of our color scheme appears. Good. Now I'm not very happy with the dark spots here. This might be due to the scale of our cells, so I will just make them smaller. Stretch them more, like 50% of stretching. And yeah, slightly they get better and better. Let's use a little less bump, 0.5. And yeah, just play with the values. Of course, we have the full color scheme if I completely plug the color output here into all colors which are available as inputs here. Yes, but that's mainly it. So you see how to append the material and work with the monster skin material as well. If this is too regular, I think it's okay now, but I can turn up the noise so that it will have a little more distortion and won't look that smooth as before. Okay. Well, that's mainly it. I don't know what to do next. I think I'm done. So you see how UV spectrum helps to color your organic models, which most of the time will have a very complex mesh, and it will save you a lot of painting time. you can think of this result as a basis to start painting on. So by painting over this coloring, you will be able to add more details by hand, and you don't have to paint the whole mesh, as UV Spectrum will handle a lot of the gradients and color ramps already. So I hope you have got a little insight in the use of UV Spectrum in combination with organic modeling and sculpting. Again, let's remember, for organic models it will be very important in which direction the local z-axis is facing, and if we want symmetry along the x-axis, then we also should check if the model is facing left and right along the x-axis. And then you're good to go to generate the maps. So I hope you liked this tutorial, and there will be more coming up soon. Until then, please hit me with your feedback, and if you have any questions, feel free to ask them. Happy blending! Bye!